Okay. So I'm making myself a chart where I'm going to pick some numbers for X and find the corresponding value for Y. And one of the first numbers I always pick for X is 0. The reason I pick 0 for X is because it's always easy. Why? Because when I put the 0 in for X, 3/2 times 0, well, 0 times anything is 0, and 0 plus 6 just gives me 6. So the first point that I found on this line is 0, 6. And I can pick any other value for X that I want. Since this is going to have a 2, I'm going to pick an even number for X. Let's say I pick -4. I just want to show you I could just pick any number. Now, what am I going to have to do? I'm going to have to do 3 divided by 2 times -4 plus 6. Now, if you have your calculator handy, this is going to be pretty easy to do. 3, remember when you're, I'm going to do it by hand. When you multiply fractions, you multiply the tops together. 3 times -4 is -12. And the bottoms are 2, and -12 divided by 2 happens to be -6. So this becomes -6 plus 6, which gives me 0. In other words, the second point that I found happened to be -4, 0. Actually, that's enough points to plot a line, because once you have 2 points of the line, you can then go ahead and graph the line. And this is what it would look like. The first point I'm getting is 0, 6. The X is 0, the Y is 6. 1, 2, 3, 4, 5, 6. It's actually a point on the y-axis, and that point is called the y-intercept. The second point I got is -4, 0. So that means go 4 to the left, and then don't go up or down because it's 0. It's a point on the x-axis, just happened to have been, I didn't specifically go to it, I just got it by chance. A point on the x-axis called an x-intercept. So we actually have found the x and the y-intercept. And if I connect the 2 points, I of course go a little bit further in each direction. Here is my line. So that's one way of graphing a line, is to make a chart of values. Pick any value you want for x, stick it into the equation, get the y value, and then put it in, and then at least 2 times. If you wanted more points, you could pick X to be 10 if you wanted to. The reason I'm picking even numbers is because I know it has a 2 on the bottom here, so the 2 will cancel out if I pick even numbers. Okay, this is not my favorite method of graphing a line. I'm going to go to my favorite method. I'm going to leave the picture on the board, the graph. I'm going to show you that this other method, using the slope and the y-intercept, will give you exactly the same picture. Again, I'll start right here. Is it okay? Everybody okay if I erase this? Anybody not want me to erase it? Okay. Does everybody hear me okay?
Yes.
Yeah.
Yes.
Great. Okay, so I am crossing this part out, and I'm going to stick with this equation, y equals 3/2x plus 6. This is what we call the slope intercept method form of the equation. That's where it's y equals the number in front of this x is the m, that's my slope, happens to be 3/2. We generally want our slope to be a fraction because the slope gives us what's called rise over run. If it turns out that your slope is a whole number, just put it over 1, because when you want to use a slope for graphing purposes, you need it to be a fraction. The number that stands alone is the b. That's what we call the y-intercept. That's why this is called the slope-intercept form. In this case, the y-intercept is 6. Which means it's going to cross the y-axis at 6. Now, it's really, the better way to say that is that the y-intercept is the point 0, 6. Because it's a point, it really needs an x and a y value. But since on the y-axis, the x value is always 0, we say that the y-intercept is 6 because it's understood that the x is going to be 0. Using this information, we can draw. I'm going to do it right on top of that line that we had before, just to show you that it actually is exactly the same line. I'm doing it with the red pen. I hope you'll be able to see this. So that one. Whenever we're using the slope and the y-intercept to graph a line, we start at the y-intercept. This is our starting point. We start at 6 on the y-axis. So here I go. 1, 2, 3, 4, 5, 6. Here's my first point. Happened to have been one of the points we had before, but that doesn't matter. We then go from that point to other points using the slope. The slope says its rise over run is 3/2, which means from this original point, the y-intercept, we're going to go up 3, 1, 2, 3, 2 to the right, 1, 2. That gives me a second point. Now, 3/2 could have also been written as -3 over -2 because a negative over a negative is positive. So instead of going up 3 and 2 to the right, I could have gone down 3, 1, 2, 3, and 2 to the left. And I could do that another time. 1, 2, 3, 2. I could keep doing this, going up 3, 2 to the right, or down 3, 2 to the left. If I connect all these points, I get this line, which is exactly the same line I got before. I like this method because once you have it in the slope-intercept form, you don't have to do any more algebra or arithmetic. You can go right to your graph and graph it right using the slope-intercept form. And that's the method that I will almost invariably use when I want to graph a line. Let me just talk about one other thing that I could have talked about on this line, and just talk about it in general terms, and then we're going to spend a little bit more time discussing the slope, because the slope is really a very important concept that we have to look at. Let's go back to this original equation. Our original equation was 2y minus 3x equals 12. One of the things that are often, and we actually found it here, that are very interesting to know about any kind of graph, not just a line, but any kind of graph, is what are called the intercepts of the graph. Where does the graph cross the x and the y-axis? As a matter of fact, when we get a little bit later in the course, we're going to be talking about graphing other types of shapes like circles or things that are called ellipses or parabolas, things of that nature. You don't have to know what they are right now, but they're not straight lines. They're, you know what a circle looks like, an ellipse looks like an oval, so those are not straight lines. One of the things we're going to be very interested in finding on those graphs is the intercepts. And the basic method for finding the intercepts is the same no matter whether it's a line or any other feature. If you want to find the x-intercept of a graph, replace y with 0 in your equation. So if I were to take this equation and I wanted to find the x-intercept, I hadn't graphed anything, I hadn't done anything, I'm just starting with the equation. All I have to do is take the y and replace it with 0. So that would give me 2 times 0 minus 3x equals 12. Now 2 times 0 itself is just 0. 0 times anything is 0. And 0 minus 3x is just negative 3x. Notice this is really quite easy to do, because if you're replacing the x with 0, any term that has a 0, that has an x in it, is just disappears. I'm sorry, if you're replacing the y with 0, which we did over here, and any term that has a y in it is going to disappear. You'll just be left with the x terms and the numbers, but the y terms are now 0, so they're not there anymore. And of course, if I have negative 3x equals 12, if I divide both sides by negative 3, I get x equals negative 4, because 12 divided by negative 3 is negative 4. In other words, the x-intercept is negative 4, 0. Remember, when you have an x-intercept, its y value is always going to be 0. So sometimes we just say the x-intercept is negative 4. And don't bother putting in the 0, because it should be understood. But the true x-intercept is the point negative 4, 0, which we see right here. 1, 2, 3, 4. Here's my x-intercept. If we want to find the y-intercept, we do a similar thing. But here, instead of replacing the y with 0, now we're going to replace the x with 0. And if you think about it, when you were going to replace the x with 0, Of course, any term that has an X in it is going to disappear. So you'll get simply 2y equals 12. Notice this -3 times 0 was 0, and 2y minus 0 is just the 2y. Just like when we replace the y with 0, any term with y dropped out. Here, when we replace the x with 0, the x drops out, and we're left just with a y. That gives me 2y equals 12, which gives me y equals 6. Again, that means that the x is 0 and the y is 6, which we knew from before that the y-intercept is 6. As a matter of fact, if I had just started with this information, it would have given me a good picture of the line, because I could have put here's my x-intercept at -4, here's my y-intercept at 6, and I can just connect those 2 points. And here actually was a third way that you could have used to graph the line. If you didn't want to put it in the y equals mx plus b form, you could have just gone to the x and y intercepts, and you could have graphed the line that way. But this is something that we're going to come back to again and again. When we want to find where a graph crosses one of the axes, we use this method. To find an x-intercept, we put the y to be 0. To find the y-intercept, we put the x to be 0. Okay, let's see if I can give you one to try on your own to see if you can do this while I take attendance. Okay, can I erase this? Okay, nobody's objecting. So I'm giving you this equation, 4x plus 3y equals 12. Find the x and y intercepts and use it. Then you could draw a sketch of the line also if you have time. But you can put the x and y intercepts on the chat when you get it. Okay, we're going to take attendance in the interim. You have to be aware when you write that the x-intercept is 3, that really you're talking about a point, and a point always has an x and a y value. On an x-intercept, the y is 0. We've already said that, so that's why I only have to say that the x is 3. In terms of the y-intercept, we can find the y-intercept in a similar way by putting x equal to 0. Take the x, replace it with 0. That means this whole term drops out, and what you're left with is that 3y equals 12. And when you solve that, you get y equals 4. In other words, the y-intercept is the point 0, 4. If I wanted to, I could use this to graph my line. It is an alternate method to graph the line. So this is really a third method that we could have used, because the x-intercept we said was 3, so that's 1, 2, 3 over here. And the y-intercept we said was 4, 1, 2, 3, 4 is right over here. And if I connect these 2 points, I get my line. So that is also a method that can be used to graph a line, but more so, it gives you important information called x and y intercepts. You know, let me see all people. Excellent, excellent. I see a few people got that right. Great. notice I didn't even bother putting it in the y equals mx plus b form because if I'm just looking for the intercepts, I can go right to the equation without. But of course, if you did put it in the y equals mx plus b form, you got it right as well. Okay, so given that, I think we're pretty secure as to how we can graph lines. I'd like to go on and talk about the whole concept of slope and the things that we can learn from the slope of a line. All right. First of all, we talked about how to find the slope of a line. We had one method that we used, which was when we put the line, I gave you an equation of y, and I told you to put it in the y equals mx plus b form. Once I have y equals alone on one side, the coefficient, that's the number that's in front of the x, is the slope of the line. Don't take the coefficient of the x unless you have it y equals, because it's only the slope of the line when it's in that format, y equals mx plus b. Now, it turns out that sometimes we are given not the equation of the line, but we're given points on the line. Let's say I give you these 2 points, 6, 3, and the other point on the line is negative 4, 8. These are 2 points on a line. Here's what that line looks like. Let's just graph it so we'll have an idea of what it looks like. 6, 3 is the point 6 to the right, 3 up. 1, 2, 3. Here's my point 6, 3. Again, if you do this on graph paper, it's much clearer. The other point is negative 4, 8, which means go 4 to the left and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And if I connect these 2 points, I have a line. And it seems obvious to me that the slope of the line is negative. Remember, as you go from left to right, if your line goes down, it's a negative slope. If as you go from left to right, your line rises, you have a positive slope. But I don't have the equation of this line, so I don't know how to figure out the slope of the line, except that there is a formula, a very important formula that you have to know that will help you find the slope of the line. This is it's called y2, I'm sure you've seen this before, minus y1 over x2 minus x1. I don't have to draw it, I can do it just by the numbers. What I do is I pick one point to be my first point. Let's call this the first point. Let's call this the second point. Then the first point has an x1 and a y1. Those subscripts are just saying the x of point 1, the y of point 1. The y2 and the x2 are from the second point. This is going to be my x2. This is going to be my y2. I usually like, when I'm doing this, to label them so that it's easy to substitute into this formula. According to that, then I should do y2, which is 8, minus y1, which is 3, over x2, which is negative 4, minus x1, which is 6. And if I do that, I get 8 minus 3, which is 5, and negative 4 minus 6. And again, if you have trouble with this, just stick it into your calculator. Do 8 minus 3 on your calculator, it'll give you 5. Do negative 4 minus 6 on your calculator, it'll give you negative 10. Usually, now that's your slope, but usually we like to put the slope in simplest form. If you notice, you could divide the top and the bottom by 5, so what you're getting is negative 1/2. I'm reducing by 5 top and bottom. Notice when I have a negative in the denominator, I usually don't like to leave it in the denominator, I just put it in front of the fraction. A negative in a fraction can be on the top, it could be on the bottom or in the front, and it means all the same thing. The slope of this line is negative 1/2, which means that if I started at this point and I could go down 1, 2 to the right, 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 I'll eventually get over here. So this is the alternate method of finding the slope of the line. If you have the equation of line, you put it in the y equals mx plus b form, and that gives you the slope. But if you just have points and you don't have the equation of the line, you can still find the slope using this equation. Okay. Let me give you one to try, and then we'll go on to something else. Okay, suppose I give you 1 point is 3, negative 5, and another point is the point negative 1, 1. Okay, find the slope. You don't have to graph it, I just want you to find the slope. Let's see if we can do this. I see we have a bunch of people who did give us answers. Looks good. Okay, so again, I'm gonna pick one point to be my x1, y1, and one point to be my x2, y2. I could have called this the x2, y2, and this the x1, y2. It's totally arbitrary. It doesn't make a difference. Just keep in mind that you want the x1 to go with the y1 and the x2 to go with the y2. So then if I stick it in, I'll do y2, which is 1, minus -5, which is y1, over x2, which is -1, minus 3, which is the x1. Now, don't forget, when you have this double negative, a negative and a negative, that will become a positive. So the top actually becomes 1 plus 5, which is 6. And the bottom becomes -1 minus 3, which is -4. So that I end up with, if I reduce this, -3 over 2, because I want to divide the compound by 2. Again, don't forget, this is one, it's not 1 minus 5, it's 1 minus -5, and a negative, two negatives become a positive. That's where you're going to have to be very careful. That gave me 6, it did not give me 4. And the bottom was -1 minus 3. So those are two negatives, gives me -4. Be careful with your signs. Everybody okay with this?
Yeah.
Okay. All right, so now I just want to talk about, first of all, the fact that I can figure out the slope. The slope, I'm going to talk about what can the slope tell me? What kind of information can it tell me? Now, obviously, one thing we said is that if the slope, if it goes down as you're going from left to right, it means the slope is negative. If as you go from left to right, the line rises, again, it's always as you're going from left to right, because this is the lower to the higher. If you're going this way, if you're going up, the slope is going to be positive. But look at this slope. Look at this line. What if I had a line with these 2 points? Suppose one point is the point 0, -2, and another point on the line is the point 5, -2. Okay. Let's figure out the slope of this line. Let's look at what this line looks like by graphing it, because it's going to be, this is what's called one of the special types of lines. There are 2 special lines that we want to talk about right now. If I use the slope formula to find the slope, look what happens. Remember, we do y2, which is -2, minus y1, which is another minus another -2, over x2, which is 5, minus 3, which is x1. I stuck it into my slope formula. Again, I have this double negative, a negative and a negative. That's going to become a positive, so that I end up with -2 plus 2, which gives me 0. And 5 minus 3 gives me 2. So that I get the fraction 0 over 2. And a fraction that has 0 as its numerator is just equal to 0. you could do that on your calculator by doing 0 divided by 2, and you will get the 0. Let's look what this line looks like, this line that has a slope of 0. Here's 3, -2. 1, 2, 3, 1, 2. Here's 5, -2. 1, 2, 3, 4, 5, -2 right here. Now, if I draw this line and extend it, you will see that this line is what we call a horizontal line. A line that goes straight across without going, it's not going up, it's not going down. As it goes across, it's just going straight across. That is what you get when you have a line whose slope is 0. A horizontal line is a line whose slope is 0. Notice the y values of the points, all the y values of the points are going to be -2. Where it crosses the y-axis is going to be 0, -2. That's because it's not going up, it's not going down, it's just going straight across. It's a line whose y values are always the same. In this case, they're all -2. Therefore, the equation of this line is y equals -2. When you have a horizontal line, it's not a line and not an equation in the y equals mx plus b form. I mean, you could, it's not technically not. It's just an equation that has only a y. There's no x in this. It's just y equals -2. That's what a horizontal line is. And the slope of that line is equal to 0. Horizontal, and this is true of every horizontal line. And you'll know it's a horizontal line when you recognize that the y values are always the same. If you have 2 points on the line with the same y value, that's got to be a horizontal line. This is something we're going to have to remember. Horizontal lines have equations with just y in it, y equal a number, and the slope of that horizontal line is 0. Now let's take a slightly different situation. Let's say I have these 2 points. Suppose I have the points 2, -5, and 2, 1. I'm going to draw this first. Doesn't matter. And then we're going to talk about the slope. 2, -5. Looks like this, 2 to the right, 5 down. Two, 1 is 2 to the right and 1 up. If I draw this line, I get a line that goes straight up and down, which is called a vertical line. A vertical line, notice all the x values are the same. This is going to be, this is 2, 1, this is 2, -5. Here, where it's crossing the x-axis is 2, 0. Every point on that vertical line has the same x value. Notice over here, we had all of them having the same y value, so it was horizontal. Here, they all have the same x value, so it's vertical. It goes up and down. The equation of this line is x equals 2. Again, it's not an equation in the line in the y equals mx plus b form because it's not a slant line. It's a line where every x is the same on every point, so therefore it has only an x value, there's no y value in the equation. X equals 2. What about the slope of this line? Well, if I went to do the slope of this line, again, here's my x2, y2. I'm going to do y2 minus y1, so it's -1 minus -5 over x2, which is 2, minus 2. So again, we have this minus and minus, which becomes a plus, so I get 6 on the top, and on the bottom, I'm getting a 0. Now, this is very strange. Of all the operations that I'm allowed to do, all the things that I can do using numbers, the one thing I'm never ever allowed to do is to have a 0 in the denominator. I cannot divide by 0. If you try it on your calculator, if you do 6 divided by 0 on your calculator, it's going to say error. We sometimes call this undefined. Undefined is equivalent to saying does not exist. The one type of line that can't have a slope, because when you try to figure out the slope, you get a 0 in the denominator, is lines that go straight up and down, vertical lines. And it makes sense that it doesn't have a slope, because the slope tells you rise over run. And here, if we go from one point to the other, we're just rising. We're not running at all. We're not going left or right at all. We're just going up. So that does not have a slope. So these are two special lines. The horizontal line, whose slope is 0. It has a slope. It's the number 0. It means it's going straight across. It's not going up. It's not going down. It's going straight across. And its equation is y equals a number. A vertical line, its slope doesn't exist. It's undefined. It's a vertical line, goes straight up and down, and its equation is just x equals a number. Notice in the vertical line, we have only x's in the equation. In the horizontal line, we have only y in the equation. When we have slanted lines, that's when we have our y equals mx plus b, where we have both x and y. So this was a special case. Notice also that if I ask you, the relationship between the vertical line and the horizontal line is that they are perpendicular to each other. Perpendicular means they meet at right angles, they meet at square corners. And when you have a vertical line and a horizontal line, you're going to get a right angle. Any question about this before I go on? Okay, so far, what have we done? We've talked about finding the slope of the line. We've talked about the y equals mx plus b form of the line. We've talked about two special kinds of lines, this vertical and horizontal. So now let's go back to our discussion of slant lines, which is more complicated than either of these. These are just things you have to remember, but it doesn't involve a lot of different calculations. It's relatively easy calculation. If I ask you what's the slope of the horizontal line, you should know right away it's 0. If I ask you what's the slope of a vertical line, you should right away know it is undefined. Okay. Let's talk about what type of information the slope can give us. Why do we concentrate so much on slope? And it turns out that there is a lot of good information we can get from lines, the slope of lines. First of all, take a look at this picture. Suppose I have this line, let's call it line 1. And let's suppose I have this line over here. Let's call this line 2. There are 2 lines. I didn't give you an equation about it. I just drew 2 lines on the board. Can you see this clearly, by the way?
No, not really.
It's not coming out clear. Maybe I have to, my thing is. Is this better?
Yes, that's better.
Is that better?
Yes.
These markers run out so quickly. Okay, so. If anything ever is, if something bothers you, please let me know, because unless I keep looking at what I'm seeing, but I don't always see what you're seeing. Okay, we have these 2 lines. These 2 lines, are slanted exactly the same amount. So that means that no matter how much these lines are extended, they will never meet. What do we call those type of lines? Lines that never meet. Anybody?
Asymmetric asymptotes? No.
No,
Parallel?
parallel, good. We'll talk about the asymptotes later on. I'm a middle class. Okay, so I have these 2 lines that we call parallel. Actually, we'll talk about what an asymptote is later on in the term, but that doesn't have to do with straight lines. Lines that are straight, that no matter how far they extend, they're never going to meet, are called parallel lines. And it makes sense that lines that are slanted the same amount are going to be parallel, because they're having the same slope. As a matter of fact, that means that you can test if lines are parallel because the slopes have to be equal. If I wanted to test algebraically if 2 lines are parallel lines, all I have to do is somehow, it's not always only, but what I have to do is figure out the slope of the 2 lines. If the 2 lines have the exact same slope, then they are parallel. But if they don't have the same slope, then they're not parallel. It's as simple as that. There's something else we can tell from slopes, and that has to do with when lines are perpendicular. The word perpendicular means 2 lines that meet at right angles. They meet at 90-degree angles. Let's say I have this line, which is line 1. Then this perpendicular line would have to be something like this, line 2, where they get these square corners at where they're meeting. These are what are called perpendicular lines. Now, obviously, the slopes of perpendicular lines are not going to be the same. Obviously, this is going to be a positive slope. This is going to be a negative slope, because this is going up as you go right to left. This is going down. It turns out that the slopes of perpendicular lines are what we call opposite reciprocals. what does the word opposite reciprocal means? Let's say the slope of line 1 is 3/4. Then the line that's perpendicular to it would have to have the slope that's the flipped over. Reciprocal means you flipped over the fraction and has the opposite sign. This was positive, this one has to be negative. Or if you started out with a -4 over 3, then it's opposite reciprocal would have to be positive 3/4. One of them will always have a positive slope, one will have a negative slope, and the fraction will be flipped over. So these are two things that we can tell when we have slopes. If we have two lines and we know the slopes of the lines, we'll be able to tell, are those two lines parallel? Are those two lines perpendicular? They might be neither. They might be just two lines that aren't parallel. They're meeting, they're intersecting, as we say, but they're not meeting at right angles. So let's see if we could do a problem that involves something like that.
So like, as long as they're parallel lines, that means they're equal, right?
As long as the lines are parallel, if the slopes are equal. The slopes have to be exactly the same number. Now, sometimes you have to reduce it. Let's say one comes out to be 1/2 and the other one comes out to be 2/4, but that's the same number. You had to be able to get. Okay. So here, I'm going to give you a problem. Here are 2 points. One point is the point -4, 2. And the other point is the point 3, -5. And I'm going to give you time to do 3 things. The first thing I want you to do is to find the slope. The second thing I want you to do is find the slope of a line that's parallel to this line. And the third thing I want you to do is to find the slope of a line that's perpendicular to this line. So we're going to have this line that's between these 2 points. I want you to find the slope of that line. I want you to find the slope of a line that's going to be parallel to this line, and also a slope of a line that's going to be perpendicular. I'm going to give you a few minutes to try that. Okay, see, a bunch of people have started giving me answers, so let's work on this together. The answers did look at least partially right. To find the slope, what we want to do is use our slope formula. Here's our x1 and our y1. Here's our x2 and our y2.
Call from Kaya.
Hi, I'm still teaching. So we're going to do our y2 minus y1 over x2 minus x1, which is going to be -5 minus 2 over 3 minus -4. Now, here's where we have to be careful. And again, you could use your calculator if you're not sure. Do -5 minus 2, you get -7. Here we have this double negative, so the negative and negative becomes positive, and I get 3 plus 4, which is 7. So I end up with -7 over 7. Now, you want to simplify as much as you can, so that'll reduce to -1. The slope of this line between these 2 points is -1. That takes care of the first question. The next 2 questions are easy. The slope of a parallel line, remember, parallel lines have the exact same slope. So therefore, since this line has a slope of -1, this line will also have a slope of -1. Parallel lines, think about it, they're slanted exactly the same amount. So therefore, they have to have the same slope. This line will also have a slope Any line that's parallel to this line is going to have a slope of -1 as well. What about a perpendicular line? Well, we said the slope of this line is -1. And we said when you want the slope of a perpendicular line, what you have to do is the opposite reciprocal. Now, this is not being written as a fraction. Usually, when we want to find a reciprocal, we want to have it as a fraction, which is -1/1. Its fraction, its opposite reciprocal is going to be +1/1, or just 1, because the reciprocal of 1 is 1. It has to be the opposite sign. This one was negative, so this one's going to be positive. And when you flip over 1, you still get 1. So that was the answer to that question. I think we're going to stop right here unless somebody has any questions. This is where we're going to be continuing on Tuesday. We have class on Tuesday. Next Thursday, there is no class. Wednesday and Thursday, there are no classes. But Tuesday, there is class. We're going to have class, and we're going to start with this concept of parallel and perpendicular lines. And what we're really going to concentrate on is, if I give you information, a description of a line, how to write the equation of the line. That's the most important part of this chapter. Again, I'm going to, don't forget to keep checking if you've done your Delta math homework. Even if it's late, make sure to do it. In the end, as long as your homework is done, you get credit for it. Anybody have any questions?